Today, let us get an intro into geometry. So far, we have been doing algebra and arithmetic related sums. So today, let us try out some geometry. Okay, now this is a very interesting sum that I came across, and if you are studying seriously for Maths Olympiad, you must have already come across this sum. In case you haven't already tried out this sum, take some time, understand the diagram and try to find out whatever is asked in the diagram. Now it is given that this is a square of side x. We need to find out the measure of x. Okay, and this is the diagram that is given to you. This is a basic application of Pythagoras theorem because the kind of the 90-degree angles or right angles that are involved in it. So Pythagoras theorem has to be applicable anyways. And then some additions to the diagram you have to make. So let us see how many of you can actually do it without resorting to find out the solution by searching it online. Now let us see how we can solve this sum. In case you haven't tried it out on your own, I definitely suggest geometry sums, especially geometry sums. Please try it out on your own. Try to find out as many angles or as many sides as possible from the diagram with the given information. And after trying it out a couple of times, if you really do not get the answer and if you feel you need some help, only then resort to looking for the solutions. Okay, now let us see how we can do this particular sum. Now it is a square of side x. So you know that every single angle is a 90-degree. All the sides are x. Okay. We have two 90-degree angles over here, but a third, if you have to complete this triangle also, a third side is missing. So let us see what we can actually do. Now, if I extend this line and extend this line downward parallel to this, this will be a 90-degree. So these two lines are equal, these two lines are equal, and their opposite angles are 90-degree. It has to be a rectangle. So this is 7, and this is 9. So what can you say about this particular line? Let us call it as O, A, B. What is the length of OAB? The length of OAB will now be 14 plus 9, which is a 23. Okay. Now, X, Y, Z. Okay. If I have to join, if I am going to join the vertex Y to the vertex O. Okay. O and Y. You end up with a triangle OYB, which is a right angle triangle. I joined the vertices O and Y and we got a triangle which is a right angle triangle of the measure OYB. Okay. In that OYB, we know the measure of OB 23. We know the measure of YB, which is 7. And when it is a right angle triangle, you know that automatically Pythagoras theorem is applicable. So OY becomes a hypotenuse. The side opposite the right angle is a hypotenuse. So I can say OY square is equal to 7 square plus 23 square. Okay. So let us see what we are getting over here. We get OY square is equal to 578. Okay. Now, you know that 578 is not a perfect square. So we know the value of OY square. Now this OY is actually the diagonal of the square. It is joining the two opposite vertices OI and Y. So OY becomes the diagonal of a square. What is the formula for finding out the diagonal of a square? It is root 2 into side. Correct. So the square of that will give me 2 into side square. My side here is x. 2 into x square is equal to 578. Or x square I can write it as 289, or x is the square root of 289, which is 17. It was just the pure application of Pythagoras theorem. The only thing that you needed to do was to make this extension. ABC is an isosceles triangle with base BC. Points P and Q are in CB and AB respectively. AC is equal to AP is equal to PQ is equal to QB. Find the measure of angle B. Okay, I want you guys to take some time and try to do it on your own. Let us start by drawing a proper diagram for this. Okay, now we have drawn the diagram and I have marked whatever was the details, whatever was given in the diagram. So this side is equal to this side, this is equal to this, and this is equal to this. Now you know that an isosceles triangle is a triangle whose two sides are equal, therefore the base angles are equal. Since AC is the base, let us say this whole angle is x, I can say that this is also x. Okay, because AB is equal to BC. If this is x, this is also x. Okay, now it is mentioned that AC and AP are equal, so this becomes an isosceles triangle, therefore the base angles are equal. So if this is x, this is also x. Okay, now this is an isosceles triangle, so if this is y, this is also y. Correct? Because the base angles are equal. Now you know that the entire angle A was x, so this is equal to x minus y. Right? Now, this side QP is equal to QB. Correct? Now, this is 180 minus y. Because this forms a linear pair, Q is a point on a straight line, so this is 180 minus y. Because this is an isosceles triangle, the remaining two angles are equally divided between here and here. So let us see what is the measurement. 180 minus y plus angle B plus angle QPB is equal to 180. Or I can say that angle B plus angle QPB is equal to y. So this is y by 2 and this is y by 2. Okay. So basically we need to find out the measure of angle B, which is y by 2. So let us see how we can find out the exact value of y by 2. In this triangle, you know that the sum of angles is equal to 180 degrees. So let us write x minus y plus x is equal to 180. Or you get 3x minus y is equal to 180. Okay. Now you have a relation between x and y. Because we cannot find the exact values of x and y, we will leave it there. And then we will try to take another triangle or another place wherein we can, find out the individual angles. Now, I cannot take this particular triangle because y plus y and this is 180 minus 2y. They will add up and the y terms will get cancelled. Same over here, the y terms will get cancelled. So, I will look at the point P. At the point P, the sum of angles is equal to 180 degree. So, I can write 180 minus 2y plus y by 2 plus x is equal to 180. Okay. 180 get cancelled. Minus 2y plus y by 2 plus x is equal to 0. Okay. Or if I write it here, x minus 2y plus y by 2 is equal to 0. I am just rearranging the terms and then I will get x minus 3y by 2 is equal to a 0 or x is equal to 3y by 2. Now I got a relation between x and y which says x is equal to 3y by 2. Already I know 3x minus y is equal to 180. Now substituting, I will get 3 into 3y by 2 minus y is equal to 180 or 9y by 2 minus y is equal to 180 or I can say 7y by 2 is equal to 180. I can easily find out the value of y. Okay. What do we need to find? We need to find the value of angle B which is y by 2. So from this I need to find out the value of y by 2. So I need to y by 2 will be equal to 180 by 7. Okay. Or the value of y is equal to 25 and 5 by 7. Okay. In the isosceles triangle ABC, AB is equal to AC is equal to 7 and BC is equal to 2. So when they say 7 and 2, basically they mean units in whichever measurement we are taking. A point D is taken in such a way that C lies between B and D. Okay. If AD is equal to 8, find the measure of CD. Okay. Now as usual, let us start with the diagram. So we have an isosceles triangle ABC. AB is equal to AC. 7. Okay, and this is given to be 2. A point D is taken in such a way that C lies between B and D. So D. Okay. Now, if AD is equal to 8, find the measure of CD. We need to find this measure. Okay. Now, there are two ways of solving this. One is by using the basic Pythagoras theorem. Believe it or not, this is such a simple sum that can be done by using a Pythagoras theorem. So let us see how we can do it. And the other method is by using another theorem which I will be introducing to you in the next class. Okay, so we will do this sum by using the Pythagoras theorem so that it is very easy for you to understand. Now, drop a perpendicular over here. Now, because this is an isosceles triangle, the perpendicular from the opposite vertex will also be the angle bisector, will also be the median. Okay, that is a basic property of an isosceles triangle. So, this will be 1 and this will be 1. Agreed? Okay, so now suppose this is x. AXD is a right angle triangle. Agreed? So, what is the measure of AX? What is the measure of AD? And what is the measure of XC? So, let us see which are the measures that we already know. The value of AX we do not know. XD is XC plus CD, which is x plus 1, and AD is equal to 8. Okay. Now, if we know the measure of angle AX, we can use Pythagoras theorem and then find out the measure of angle, measure of the side, this. Okay. Now, how can we find out the measure of AX? AX is a right angle. This line is at 90 degrees to the base. So, this is a right angle triangle. Similarly, AXB is also a right angle triangle. Okay. So, triangle AXB. I know the measure of AB, 7. I know the measure of BX, which is 1. I can find out the measure of AX. AX is the altitude. So, I can say AX square is equal to hypotenuse square minus base square. Or I can say 49 minus 1, or this is 48. I can say AX is equal to root of 48, which is 4 root 3. So, now I know the measure of AX. This is 4 root 3. Now, for the triangle AXD, you know that AX square plus XD square is equal to AD square. Let us substitute the values and see what we are getting. Here, I have substituted the value of AX, XD and AD. 4 root 3 the whole square plus x plus 1 the whole square plus 8 is equal to 8 square. I have opened the brackets and now I have transposed all the terms to the LHS. I am getting a quadratic. I am splitting up the middle term and I am getting two factors over here. So, from these two factors, x is equal to either minus 5 or x is equal to 3. X equal to minus 5 is not possible because it is a negative value, and because x is a length, it cannot be taken. So, the value of x is equal to 3. This was again an example of another sum which is easily solvable by the Pythagoras theorem. So, till I upload the next video, please keep practicing, and if you want more sums of this kind or you want tougher sums, you can mail me at the mail ID given below in the description box, or of course you can search online too. Okay.